Hello, everyone. Welcome, Rachel. I'm super excited to introduce Rachael Tatman today. She's a senior developer at Rasa, and she helps to use software and open source software to build chatbots for developers. And previously, she worked at Kaggle and also did a PhD in linguistics. Today, Rachel's gonna talk about testing, validation, and evaluation about NLP system, like how do you know if your NLP system actually works. If you have ever built or thought about building an NLP system, you probably have run into some of these questions. And luckily, we have Rachel here to answer some of your questions today. And her talk will cover the differences between testing, validation, and evaluation of the NLP system. And she will also walk us through an example with the chatbot system. And don't forget to use the chat to ask any question if you have for Rachel. And yeah, over to you, Rachel.
So let's talk about testing, validation, and evaluation. Had a great intro from Xiao. I'm a senior developer advocate at Rasa. We have an open source framework for building chatbots, which is all to say that I work on chatbots. And I think, oh, thank you, David. I think that there is a pretty strong bias that a lot of people have around chatbots. So we're just going to talk about the elephant in the room, which is that a lot of people hate chatbots. So I have a couple of examples here of tweets of people talking about how much they hate chatbots. So this person is trying to get to some information about billing or payments. They have three options, A, B, C, D. The B option is uppercase B and then a parenthesis, and that's being rendered as a sunglasses emoji. And when they type it in, it is also rendered as a sunglasses emoji. And so even though they're doing exactly what the chatbot is telling them to do, it's not working. Another example here, this person also hates chatbots. So there's a chatbot that's saying 1 p.m. or 1 a.m. He says 1 p.m. And the chatbot misidentifies that and says, did you say 1 a.m.? And Owen here attempts to correct them by saying 1 p.m. But the chatbot doesn't understand and is continuing to ask if they mean the time that they do not mean. So very frustrating for the user and also very frustrating for me as a developer and somebody who works with developers, because if people genuinely hate using your system and don't want to use it, somewhere there's been a failure of engineering, or I suppose design, but I'm an engineer, so that's what I tend to think about. And it's not inevitable, right? There's nothing that is true about chatbots that makes it necessary that interacting with them should be frustrating. So given that, how do you build, deploy, and maintain an NLP system that actually works? So, of course, I'm going to be talking about chatbots because that's what I work on. But a lot of these things are generally applicable to any system that interacts with language. So there's 3 steps that I really want you to think about as part of your engineering process. And I would guess that particularly if you have a machine learning background, 2 of them are probably on your radar. The third one may or may not be. So testing, validation, and evaluation. Testing. This is, ye olde software writing tests. So this is for stable behavior, things that should always be exactly the same, maybe specific edge cases that you want to make sure that your system can handle well. Both unit and integration tests are making sure, this chunk of code does what you think it should, and that once you've deployed it, it continues to do what you think it should. So the example with the sunglasses, I would say, is probably a failure of integration tests, because either the keyboard or the platform where the person is using the bot is what's making that B : into the emoji and causing the error. And for chatbots, the way that we recommend writing tests at Rasa is you have a whole conversation where you write out what this imaginary user is saying, how your chatbot should understand that, and what it should do next. So all of these conversations, your test conversations, should always go exactly the same, no matter what updates you make to your chatbot. So testing, very important. Hopefully, if you're following best software engineering practices, already on your radar, already something you're thinking about. Validation. So to speak to Reg's question here, this is model validation. And this is part of a machine learning workflow, and it's the way that you make sure that your machine learning model has correctly extracted the right amount of information from your training data. So overfitting is that it has extracted too much information from your training data and always expects things to look exactly like the training data, which is very rare. Underfitting is that it hasn't extracted enough information from your training data, so you have very low performance. And you may have seen these sort of training cross-validation curves. Basically, you want them to touch and not to diverge from each other as you continue to add examples or training iterations or epochs, whatever it is that you're working on. And the purpose of this is to evaluate model performance when your model is presented with novel data. Again, this is really more part of a machine learning model. If you have a completely rule-based model, you don't really need to do this. And the test-train split that you may be familiar with, or your cross-validation, is really just the first stage of validation. So that's what you do when you're prototyping models, when you're doing your model selection. Once it's deployed, you can probably expect your system to encounter changes over time, particularly if you're working with language data, because language changes. So I think a great example of this is think about the last time that you heard a word that was completely new to you, maybe some sort of slang term you hadn't run across. That is something that has now entered the language and your model might have to deal with. So you'll need to revalidate with timely data, data from the time points that you are working on. I think a really good example for language data is a lot of people who are working on bots had to add the capability to handle people asking about, quarantine or disease safety prevention measures that they hadn't had to deal with before. So in general, you want validation data to match the distribution of the data that you're actually seeing in production. And if you have your chatbot in production, luckily you know what data it's seeing in production because it's available, and you can use that. And so here we have just a confusion matrix, and this is actually from Rasa's automated validation. Well, it's not automated. You can automate it from our validation, which is part of our testing suite, which shows you the confusion between the predicted next action and the actual next action. And this is another really good example of what this looks like in practice from Heather. If you are, a big person on machine learning Twitter, you might already know Heather. She's a principal machine learning engineer at T-Mobile, and her team has an enormous assistant. They have more than 2 million insights a day, so more than 2 million, machine learning insights are served. And something that I think is really impressive about this particular project is about a third of users who log into T-Mobile and encounter the option to use Heather's Teams bot choose to. So they're choosing the chatbot over talking to a person right away about a third of the time, just because it can help them do what they need to do faster. And one of the things that they do as part of their workflow is they do validation. So I know this font's a little bit small, but basically they have a notebook, a Jupyter notebook that has both code and text interspersed. It loads in their model that they're considering changing for their assistant. It pulls a month's worth of utterances and predictions. So utterances are, things that are said either by the assistant or by users, and then the predicted labels. And then it compares the new model against the current model and looks at all of the differences and then presents those out. So this is a way to do timely validation with new data to make sure A, that your model still works, and B, that the new model that you're working on works just as well or better. And then finally, evaluation. And I think it's really important, particularly in teams where you maybe don't have, a full-on product manager, and really it's just an engineer doing most of the work by themselves, which is, pretty common with building chatbots, to zoom out a little bit and make sure that you know what it is that you want your assistant to do, and that you have a way to measure that it's doing that. So you can have 100% test coverage, in theory, and also fantastic cross-validation. But if your assistant can't have the conversations it needs to be having for whatever reason, it doesn't matter, right? You've just wasted a lot of engineering effort. So what success looks like for a specific assistant is really going to depend on the situation where that assistant or that chatbot is deployed. Maybe you are doing it to save money. Maybe you need to, reduce the time that you spend on repetitive support requests to make sure that your support team has time to go in depth on the actual, more complicated support requests. Maybe you just want your users to be really happy. Maybe it's a game or something where the the good outcome is that users continue to use it and have a good time. Maybe, and this is my favorite, you save users time so that it is faster for them to do something using a chatbot than it is by talking to a person or clicking through a GUI or filing a support ticket or any of those other avenues. And there's a really good study from 2017 that I recommend if you work in the space that shows that the #1 factor that makes people actually like using a chatbot, and I would probably extend this to all NLP systems, natural language processing systems, is that it saves them time. So it's very system dependent. It's very dependent on why you decided to allocate time and resources to building a chatbot in the first place. But it's the first thing that you should figure out when you're scoping your project. And it's something you should be constantly checking in on. Okay, my tests are great. My cross-validation is great. The model's, as accurate as it can be. And we have stable behavior that we want. Are we doing the thing that we built this to do effectively? So I think all of those examples, except for the one with Heather, was a little bit theoretical. So what does it actually look like in practice? And again, I'm going to talk about this in more of the chatbot domain, but our sort of approach to handling all of these steps together at Rasa is something that we call conversation-driven development. This is sort of a play on test-driven development, if you're familiar with that. And the basic idea is that people have conversations with your assistant, or for any other NLP technology, people use that technology and give you feedback on it as part of the development process. So basically, I like to describe this as human labeler in the deployment loop. So it's not quite human in the loop. Your assistant runs on its own. But as part of the maintenance process, you have human labelers look at those interactions and figure out what worked and what went bad. And you do have to look at your data. I'm afraid there's no getting around it. I know the promise of machine learning is that everything will be automated and you'll never have to do repetitive tasks by hand. But it turns out that in order to do that, you do need to do a lot of repetitive tasks by hand to show the assistant or whatever project you're working on how it's done. So CI/CD is another way to think of it, continuous integration, continuous deployment, but including data labeling and retraining. So you have that iterative process of improvement. You don't train a model once and then deploy it. And one more time, we're going to go over this in more detail, but these are the top line points. You have to look at your data. Any language project you're working on, you need to look at the language your users are providing. You need to look at the language that your system is providing. You just have to do that to evaluate it, right? Language evaluation is not a solved problem, and it really needs a human touch. So there's sort of 6 general steps here. So sharing here, sharing with users. We'll go over all of these in more detail. Reviewing what's happening, annotating, adding more training data, testing the assistant, tracking what it is that you care about, making sure those numbers go up or down, fixing, and then really just coming back and forth and hitting all of these steps as needed, both during deployment and also after deployment. So sharing, users will always surprise you. I think anyone who has worked with a lot of user-generated data or user-generated text in particular will probably be very familiar with this phenomenon. There's no way to guess everything that somebody's going to want to do with a language system. So as soon as possible, get your prototypes in front of users, regardless of the type of project that it is. A little snarky bit here. You do need to have test users. It's just never going to work if you don't actually get it in front of people. Well, another way to think of it is you're going to have test users, and you would prefer that they know that they're test users and they don't think that this is a finished policy system that can help them out. Reviewing. So this is the looking at your data stage. At any point, it is a reasonable thing to do to peek at your data, see what's going on, assuming that you have permission for that, and seeing what people are saying and how people are trying to use your assistant and what their instincts are and the types of conversations that they are attempting to have. So language data is, like hard to measure. So metrics can give you some information, but they're not going to give you the whole story. You really need to look at it with your human eyeballs. And then annotating. So a pretty common area of research, and I would say research because I don't know of anyone who's doing this commercially, to my knowledge, is to generate synthetic training data. So basically have 2 bots that talk to each other. And I think the intuition there is at the end you might get 2 great bots, but the actuality is that in the end then you usually get 2 bots that are really good at talking to bots and not good at talking to humans. So better than that is to take the user messages that you have that you know are drawn from your target distribution, right? And use them as training data so that your system can handle them better. And then testing. So basically every time you make a change to your model, you make a change to any of the steps in your pipeline, you're going to want to make sure that you have testing. You need to make sure that your stable behavior remains stable, both unit and integration tests. And we recommend using conversations as tests. So sample conversation, it should go like this. And you can do that with pretty much any NLP system. Sample, input, output, it should go like this. And then tracking. So this is where you really want to make sure that you know what you are targeting. And as part of your deployment process and your updating process, you are evaluating it. You're using your evaluation to make sure that that target is getting better over time, or at least not getting worse over time. And sometimes it can be helpful to look at, I was trying to highlight. Sometimes it can be helpful to look at things that people aren't doing. So if people are coming to your assistant and they're having two-turn conversations, but each person only has a two-turn conversation only once, and you open it up and they ask a question, they get an answer, and they just leave right away because that was the right answer. That's great. That's ideal. You've saved people time. Good chatbot. And then fixing. So like any software product, you want to make sure that you have a maintenance plan, that you are continuously improving, expanding or removing functionality as needed. And if you're having a lot of successful conversations, you can use those as texts. And if you're having unsuccessful conversations, you can use those as data to annotate and retrain your model and get better performance in the future, hopefully. And it's all a very iterative, wibbly-wobbly process, right? Again, pretty much any software development project. I wish I could say, here's the 4 steps. You only need to do each of them once, and they're not going to take once, and they're not going to take very long. But particularly a project that has a lot of complexity, where you don't want it to fail, which I would say is most of them, you're probably going to have a little bit of iteration, again, before the product's ready to go live, and also once it's live to make sure it's continuing to work and continuing to improve. All right, so those are the 3 big things that I wanted to talk about, and also how you can put those into a broader software development process for NLP projects. So testing, what's the expected behavior? Can you make sure that it's happening both within your assistant or whatever your project is, and when that project is integrated into other projects? Validation, if you have any machine learning components, do your models continue to be effective models of the phenomena that you want to capture? Are you getting enough signal from your data? Are you getting too much signal from your data? Do you have overfit models that are creating problems? And evaluation, why did you build this? Are you doing the thing that you built your project to do, and can you provide evidence of that? All right. And that is everything that I had. I want to leave plenty of time for questions because I imagine there's going to be lots of thoughts and things to talk about. Also, this is my Twitter handle, so if you also want to ask me questions on Twitter, I'm pretty active there.
Yep, I see a few questions coming in. Rec here, he wants to know if he used chatbot because he has a test record and was discussed, and what was action needs to be taken. Do you have any suggestion for him, how to validate or test or?
So obviously that's a very brief product, a brief problem description, but based on that description, it doesn't sound like that needs to be a conversation, right? It sounds like what you would like your system to be able to do is to look at this text record and identify the correct next action. And if that's happening iteratively and you need additional information from the user, then maybe a chatbot would be the best place for that. But to me, that sounds maybe a little bit more like a sort of more general text classification task where you're trying to, given some input that you featureized, arrive at one of a set of identified outputs, or potentially it might be a summarization task where, given text input, you're trying to identify the part of the text that is the most relevant. So again, very brief product description. That it might not be a chatbot project, which chatbots are good for what they're good for, and it's not most things. They're pretty they're very useful in a narrow number of domains.
Yeah, I hope that answered your question, Rick. And Saul here asked that where are a few sources that we can get training data if we're starting this for the first time?
Yeah, that's a great question. It depends. So one thing that you can do to reduce the amount of training data that you need, which may be the most effective solution for a lot of folks, is you can use some sort of pre-trained featureizer. So this is a component in a pipeline that will take in text and turn it into numbers. And a lot of featureizers, that's sort of a general term there, things like embeddings, things like potentially even something like a language model that have been trained on a lot of data can help to give you a warm start, basically. So you're not, you don't have to train from like, all zeros, basically. So that would be my first thing to look in, would be doing some pre-trained model usage. The second question, I think the second part of that question is, okay, so even if I have that, I'm still going to need data that is relevant to my application. I wish there were an easy answer that I could tell you that was just like, here's where all the data is. So depending on your application, there may be publicly available data that will work for you. Some good places to look for that. I would say Kaggle has a lot of data set hosting. I mean, I used to work there, so I'm very familiar with the data set hosting there. A lot of times you might be able to find a shared task for an ACL conference or some sort of research conference where a bunch of people are working on a specific data set, trying to build systems to do the same thing. And sometimes those data sets are open. For commercial products, be very, very careful about the license. I mean, talk to a lawyer, make sure that the license that the data is licensed under is applicable for your use case. And if there is no license, you basically can't use it commercially. So that's sort of the second thing where you might look for data. But the third place where you might look for data is you're probably going to have to do some degree of data creation yourself. If you are using, again, I work mostly in chatbots these days. If you are using, a warm spot, you're using pre-trained embedding, some sort of pre-trained featureizer, and you don't have a very large number of intents, I would say if you have under, 50 intents, you might get away with as few as 7 to 12 training examples per intent, particularly if there's not a lot of overlap between them. But yeah, it is very likely that particularly if you are building a very custom system for a particular use case, you are going to have to do some data creation yourself. Sorry.
And the question from Tassim, I hope I pronounced your name right. How much of these approaches apply to the other NLP questions, e.g. classification?
Yeah, I would say pretty much all of them. So let's go back to, sorry, I clicked out. So let's talk about, say, sentiment classification. So for sentiment classification, why are you building a sentiment detection model? Is there a specific behavior you want to predict before it occurs? Are you using it as a proxy for the success of a secondary system, maybe looking at how people are talking about something? Are you using it to provide data for analysts? Like, why are you building the system, right? What do you want the outcome to be? That would be sort of the first step, which I have here third, is that evaluation step. For validation, only relevant for things where you have a machine learning component. Many classification systems using modern techniques will have a machine learning component. Some of them won't. If you're using regular expressions, you don't need to worry about validation. And then testing, I think, is a very useful thing to do in general for NLP systems, in particular in building trust, right? So if I say, hey, for my testing, I want you, product stakeholder 1, and you, product stakeholder 2, to write 5 really angry, 5 things that somebody might say if they were really angry, 5 things people might say if they're really happy, 5 things people might say if they were really sad, and then using that for the testing data and say, hey, this was the data that you provided, here's how the system works on it, and as we do updates on the system, we can make sure that it's still having stable behavior. Also with something like a sentiment analysis system or other classification, showing that it works in the rest of your pipeline, right? So that, you know, if you add this to another existing NLP pipeline, your dimensions are all the right size. You don't get any sort of error about that, that it works across platforms, that it can handle, you know, non-ASCII input, which might be important for your particular application. So I would say this is a sort of a general framework for evaluating NLP systems. To give it a concrete example, I talked about chatbots because that's what I do. So pretty much all of it. This step, if you are not getting user data, you can probably take out the annotate step.
Okay, a follow-up question from Sol. If I want to make my own training data based on various intents, what can I do? And should I be doing the surveys?
Yeah, good question. It depends. So if you want to get examples of intents from people, I would actually recommend this sort of general process. So having an assistant, and you can start with the absolute bare bones, right? You can start with an assistant that says, hi, here's what I do. What do you want to do? And get that information from people. Usually I recommend, once you have a lot of those interactions, assuming you're collecting them yourself, often if a system is going to go alongside or as a way to sort of reduce the support load for a human operated system, you might have chat logs already, in which case you can go through and pick out turns and label those. I have a video on the Rasa YouTube channel. I think it's called Training Data and Rules, that walks through the process a little bit more detailed. Yeah, so that's one option. We also have a repo that I don't know that is being actively maintained, but it's called Rasa NLU Examples. I'll pull it up really quick, which has some examples of various intents that might be a good place for another warm start. Let me pull it up. Nope, I don't actually think it's called Rasa NLU Examples. Sorry, I was wrong about the title. Let me see if I can find it. NLU training. Sorry, I'm having a hard time finding the repo, but somewhere in the Rasa GitHub, there's a repository where people have provided some examples, but it's not super big. And I see a question from Reg. What is the tool set that you use? So for, I mean, maybe obviously we really believe in this workflow at Rasa. So we use Rasa open source, which is free and open source, to build the bones of the assistant. And then for the rest of the lifecycle with the sharing, the annotation, the reviewing, we have built a free to use project called Rasa X. So this screenshot here is from Rasa X. Oh yeah, you can see my cursor. And you could go through and do all the annotating in this window. If you are labeling, if you're just like straight up labeling examples, there's a Spacey project that I don't remember the name of, but it's by the Spacey folks, just for speeding up that annotation project. And if you're asking about frameworks, this is Rasa's all built in TensorFlow.
Cool. And Subashia has a long list of questions.
And so I'm looking around my mic. When training an NLU model using Rasa with the predefined Rasa pipeline components in a config file, training data doesn't seem to contain all possible values of examples, with expanded combinations of entities substituted with variations from its synonyms. In short, the entities are not getting substituted with different synonyms. Is this the way Rasa is designed? Any workaround? Do I need to write my own custom synonym replacer? And what is the entity synonym mapper doing inside Rasa? Great question. So there may have been updates recently, by the way. Prodigy, thank you, Shivari. Prodigy is the Spacey NLP data labeler I was mentioning. So the way that the synonym mapping works is, I believe, and I'd have to double check the most recent version of the docs because it's been a while since I wrote a bot that had synonym mapping, is that if an entity is extracted, all of those entities, all of the synonyms will be mapped onto a single entity. So it's basically reducing the number of classes that you have. And I don't believe the thing that you're asking about where the there's like a plug and replace is done. But again, I'd have to check the most recent version of the docs. And was there another one? Yeah, and if you're just looking to do like combinatoric replacement of specific synonyms for like data augmentation, I don't have strong intuitions that that would help, right? Because there would be so much, the rest of the matrix sentence would be the same and you'd just be replacing the synonym with a different synonym. Because we use conditional embeddings, right? A synonym that's showing up in the same matrix sentence should always already get the benefit of the matrix sentence. And also, because those synonyms should share very similar embeddings, they should also, benefit from the other synonym being in the training data already, if that makes sense. My guess, and this is just an untested hypothesis, let me know if you do some experiments. My guess is that that would increase training time, but not dramatically improve performance, or it would overfit on specifically the instances you had with synonyms. Sorry, this may not be as relevant for everybody, but that's my intuition. Oh, thank you, Shivari. And Ratavaj, I'm sorry if I'm saying that wrong.
I think these are going to be very helpful, like for people who are using Rasa or not using, haven't tried Rasa yet.
And just as a final wrap up, you need to do all three of these things. You need to run tests, make sure that your stable behavior is acting as expected, that you can handle edge cases well. You need validation, make sure that your model is neither over nor underfitting, including on the data that it's currently seeing. And evaluation, you need to make sure that the reason that you started doing the thing, you are successfully doing. Or at least improving, right? It doesn't have to be perfect, but it should be getting better over time.
Is there any more questions for Rachel? We have 2 minutes left for this session. If not, yeah. Thank you so much, Rachel.
Thank you for having me.